So this, thank you. I think that must be Chakin. So let me just edit my name here so that you won't confuse who is speaking. So those are our today's tools. And also for the slides, before we start, let me share the slides as well. Downloads, documents. So those are the slides that we are going to be using. Anyway, hi cousin Chakin, how are you? You can say hi to your cousins.
Hey, good morning, cousins. Good to hear you and good to have you here. It's gonna be awesome. It's gonna be awesome. I won't be in for the whole session, but partly in kidogo just to enjoy the session. My reminder to you guys, I hope you've done your nice assignments. I hope you've dealt with assignments very clearly. Because remember, if you delay, time waits for no man. So, and there's a going, every week has its own assignment, new requirements of the assignment, as you have seen. So, guys, I expect you to really be on your, I think on your toes when it comes to assignment. That's the place to be, making sure that you've done your assignment. There are some groups that have invited me to see how they are journeying along, and I'm happy to be invited in those meetings when your group meet. Yeah, you can always invite me when your group has a meeting. I'll be very happy to attend and see what you're doing. Yeah, so make sure your group is functioning, make sure your group is working. I hope your blog is ready. You know, last week assignments, we were submitting blogs, we were submitting presentations, GitHub repos, and what have you. So I hope they are all ready so that your assignment can be also certified. And also, remember, we will start reviews this week as agreed last week that this week we should have the reviews of assignment work one done. So I'll do that. Me and Evans, we will do the reviews and the results. You'll have the results before Friday. So expect the results before Friday. We will tell you what you did and how you did as a group. Okay. Cool. So that is cool. That's all from me for now. Yeah, JS Daddy, my cousin Kuzo. JS Daddy, take on.
All right, all right. Thank you, Chakin. Today is going to be a good day. We have a lot of energy that we are going to have anyway. So, just to repeat for those who just joined, our main tools for today, or our trial tools, we are going to be using Google Colab in case you want to try it. If you're open to use VS Code, Casa, and any other tool that you can try or you use for your coding. So yeah, feel free to use any tool of your choice. So just get that ready. And also for our research, as usual, you're going to use ChatGPT in case you get in stuck. Then your ChatGPT should be open, or any other AI tool like Claude and any other tool of your preference. I've already shared the notes, the slides for what we are going to be using today. So you can get them, can re-upload them again. And for those who will have the notes, you can keep sharing to your friends who will keep requesting the notes as well. And of course, we are in week 3 of the LMS. So you can open your week 3 LMS for reference. That is week 3 in the LMS for AI for software engineering module. So let's get into it. Let's go to our presentations. So what we are going to do today, we are going to learn AI tools. AI for software tools or AI software tools. So why are we learning these specific tools? These tools will help you do several things. Train your AI models, access different data points, perform different tasks with these AI tools. And some of these AI tools that we are going to cover today is like the Keras. This is the Keras scikit-learn. We are going to learn the Caffe. We are going to use TensorFlow, Microsoft CNTK, and Jupyter. Of course, we have been using Jupyter before specialization, so that should not be a new tool for us. Yes, and any other tool that we will come across in our learning. So these are the AI tools that we are going to cover today. We are going to see why the AI tools and where best you can use these tools in your daily activities when working around AI and also machine learning in that case. So yeah, we can begin learning. Of course, these are the outline. This is the outline of what I just covered. We are going to check introduction of AI tools, TensorFlow, going to cover that, PyTorch, Keras, scikit-learn, Jupyter, Caffe, or whatever you pronounce it, Caffe Cave, how you pronounce it, and also the Microsoft CNTK. So all this we are going to run code and see different codes and explain how the code is working. Where are we getting the codes? First of all, it's nothing new. It's already in the LMS. We're going to use these demo codes to try out and explain what these different pieces of code is doing. Yeah, so let's get into the presentation. And as we continue, someone can notify if you can hear the slow background music. Can you hear the slow background music? Is it distractive? If it's distractive, you can just tell me. Is it distractive? Ruth is saying it's distractive. People are saying no, yes, yes, no, 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 not necessary. It's not distractive. It's okay. People are saying it's okay. So we can just keep playing, pausing, play, pause the music. Okay, I can just pause the music for some few seconds, then we play again, pause and like that. Yeah. Thank you. So let's focus. Pause and focus. Let's focus on this. Let's focus on this. Let's focus on this. Yeah. Introduction to AI software tools. So here we are going to check different libraries and frameworks and how we can play around them and how we can achieve the best. So why these AI tools? These AI tools are used in different cases. For example, for to simplify our building process, our AI training models we can simplify with different tools, and how best we can deploy AI models. So that's the purpose of these different tools. Each tool has its own unique value and how best you can use it. So those are the AI tools that we are going to cover and the goal or the purpose of learning these AI tools. So you guys can embrace open source. If you are building an AI tool and you would like someone to assist you, you can embrace open source. And open source is access to all. What is open source? Maybe open source is like you are training an AI model, you think it's useful, you want people to use it openly without any interference, without paying for certain things. You can open source your models and all these things. AI, we believe AI that should be open. AI should be open to be used by all. So you can check some few wisdom here we shared with you. A tool is only as strong as the community. Yeah, we know that any tool that we use is as strong as its community. Why do we know Twitter? Twitter is strong because of its community, how people are open there at Twitter. We know WhatsApp is strong by its community. Facebook is strong by its community. AI tools are strong by its community. OpenAI is strong. Cloud AI, all those different tools are strong because of the community behind the tool. Python is strong because so many people are using Python to do meaningful stuff. So that's why we say a tool is strong as the community behind it and making it a success. So I would like the session to be interactive, and I already shared this. I already shared these notes. So in case you want to check out the notes, I already shared on the chat. Now let's begin our first tool, that is the TensorFlow. TensorFlow is a tool developed by Google. We know Google. Google has developed so many tools, programming languages, and other different tools. Like the tools that we use, the search, the Firebase databases, the cloud, the Google Cloud for us who host our application in Google Cloud. And of course, we have this amazing tool for training AI and using in AI different kind of stuff, that is TensorFlow. Why TensorFlow? Why TensorFlow? Why do we need to use TensorFlow? Or why do we need to learn TensorFlow? TensorFlow helps us create scalable and production applications. TensorFlow, when you are using TensorFlow, that means you're going to have an easy time. And of course, if you are building a large, maybe when you are working with large data set, TensorFlow, we are pretty sure that is going to handle our data, our training, our everything with ease. So we embrace TensorFlow. It's an open source. Anyone can use as much as they want. You don't have to pay to use TensorFlow. Yeah, you don't have to pay to use TensorFlow. So where is TensorFlow mostly used, or where is TensorFlow is good at? It's good at everything, literally everything. So best, you can use best TensorFlow in natural language processing, in image recognition, and also in recommendation systems or recommendation engines, like YouTube. I'm pretty sure YouTube's at some point uses TensorFlow because depending with your algorithm, what you watch, what you consume, it can build a very good recommendation system after understanding you. Yeah, yeah. Just as the example, here is where TensorFlow powers. TensorFlow powers the Google search. TensorFlow basically powers your Google search, powers your YouTube, and your most favorite apps. And we are going to see different apps and where you can use them. Actually, we can read one of the Ubuntu wisdoms that we think relate to TensorFlow. So if you want to go far, build roads others can travel. So if you want to go far, of course, build a tool that everyone is comfortable using. And one of the tools that people are comfortable using is the TensorFlow, in which you are going to see how you can use TensorFlow in your daily to daily basis. So don't worry, whenever we are going to the demo part or the practical part, you are going to see how best we can do image recognitions and we can handle images, natural language processing with TensorFlow. So never worry, never worry. The practical part are going to teach you more about TensorFlow. So this presentation is all about summary and just getting to know where and how you can use these tools best. The next tool is PyTorch. PyTorch. What do we mean by PyTorch? PyTorch is another tool that was developed by Meta. What is Meta? Who is the founder of Meta? Who created Meta? Maybe I can see from the chat. Who is the founder of Meta? Who is the founder of Meta? Zuckerberg. And what are some of the projects under Meta? What are some of the projects under Meta or applications under Meta? WhatsApp. Oh, thank you. You guys are done. Instagram, Facebook. I can see IG. Yeah, thank you. Awesome, awesome. And Llama. Yeah, thank you. Someone who, Alex, you said Llama. Of course, we are going to use Llama models at some point. I'm pretty sure. And what are some of other tools apart from Facebook, Llama, IG, WhatsApp? What are other tools you guys know that are under Meta? Meta. Awesome. I was waiting for this. Thank you, Kevin. Kevin, yeah, React itself was developed by Meta. We call it Meta. It's a Facebook product. It was developed by Facebook engineers. React JS is owned by Meta, by Facebook. And we have those Horizon Worlds. Yeah, thank you. Awesome. Thank you. I think you guys are really pretty sure. And you just forgot to mention that the tool that we are going to use today, that is PyTorch, is also developed by Meta. So those are some of the tools. And we have these glasses, AI glasses. What do we call those AI glasses that were developed by Meta? What do we call those AI glasses developed by Meta? They're just normal glasses. You can research and tell us what are these glasses developed by Meta. Yeah, we know Meta. Of course, if we are using Meta, any tool that was developed by Meta, we are pretty sure that Meta is going to give us a great product. And one of them is, of course, PyTorch. PyTorch is a superpower tool, and it's used for to create some Pythonic joy, some dynamic computing graphs. You want to achieve anything graphical with AI, then PyTorch is one of the best tools out there that we are going to learn and that we are going to use. Why is Meta, not Meta, but PyTorch mostly used and best used? Used for prototyping, in academia, in bleeding edge research. And we are going to see all this kind of stuff when we get to the practical part. Okay, we have some not Meta, but Ubuntu wisdom here that we relate, a quote that we can relate with PyTorch. So share your torch and light the path for others. So as engineers who don't want to develop these tools, PyTorch is our torch that is going to lighten up our AI and prototyping projects to do with AI. So yeah, something that we can really create. And why PyTorches, of course. PyTorch is used by, I think over 70% of AI researchers, they use PyTorch. Yeah, it's a good tool. It's a very amazing tool. You guys, you are going to enjoy when learning these tools. So far, you can see we are learning big tools, very big tools with big name, with big English. Kizungu kubwa, Kizungu kubwa, very big English with PyTorch. Let's see another tool, another tool, another tool. Another tool is Keras. Keras. It's a superpower. When you want to achieve simplicity, Keras is the Go tool that we can use to achieve our simplicity when it comes to different functionalities. Okay, what is Keras? In other ways, we are going to see more details about Keras when it comes to the practical, when we see the practical use of these tools like the Keras and the rest. So Keras is a tool that is used by TensorFlow's front end. How? What do we mean? Another scenario. You remember when we were learning Python libraries. In Python libraries, we learned the math. In math, when you import the math, we have different tools inside the math, the multiplication, addition, division, and other tools. Now, when we have TensorFlow, then that means we already have Keras. And Keras is just one of the tools inside the TensorFlow that is going to enable us just to achieve some simplicity when it comes to building our neural networks, activities, and projects. So you don't have to worry. These are not difficult tools. They are very, 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 very simple tools. So you don't have to panic. You don't have to worry, man. These are very simple things you guys need to learn. Ignore what people are saying out there that building AI is hard. No, ignore that. Ignore that. It's very simple. Using AI, it's very simple. All right, some wisdom. Some wisdom. We can share some wisdom. Complexity shared becomes simplicity achieved. So you can relate this. You can relate all these things here. All right. When we are using Keras, we are going to see that we said it's just simple. It's going to achieve simplicity. That means it's going to execute with very less time. So I was trying to run some pieces of code, and these pieces of code were executing very fast, very fast. So you don't have to worry, guys. These are very simple tools. So this is just an overview of these different tools that we are going to use. So another tool, that is the scikit-learn. The scikit-learn. So anyway, guys, if I'm too fast, you can just tell me I'm too fast. Yeah, someone just said the glasses that are developed by Meta is the Meta Ray-Ban. Yeah, it's the Meta Ray-Ban. Yeah. Joy saying I'm good. Yeah, you're good. You're good. You're good. Thank you. When we get to the pace is okay for now. Yeah, the pace is okay. This is just an overview. This is just an overview. Once we go to the demo part, we are going to slow down, explain bit by bit. Understand what is this and this, what we are talking about, man. So another tool that we are going to learn is the scikit-learn. The scikit-learn. You can either call it the scikit, the skit-learn, whatever. Depends on how you first heard it being pronounced. The scikit-learn. Remember that English is not our first language, so yeah, we don't care butchering the language. We don't care as long as we understand. Scikit-learn. So scikit-learn, how can you use scikit-learn? If you want to create consistent APIs for non-deep learning tasks, scikit-learn is the tool to use, is the tool to choose when you want to achieve some consistent APIs. And API is basically application programming interfaces. You are going to see different examples of APIs. And APIs, basically, for those who don't understand APIs, APIs are links. APIs are links. So let me just share an example of API. An example of API. Let me share. Where is it? So an example of API for those who keep confusing what API is. You see this link here. This link here is an API. This Zoom link here is an API. So how do you use this link? Use this link to access resources in the backend. So what resources do you use with this API? It's very simple. You use that link to join this Google Meet. So that's an API. You don't have to overcomplicate these things. This is just an API. APIs can be different things. So you don't have to worry, what are these API we are talking about? No, it's nothing complicated. So we said scikit-learn. You can basically use it for consistent APIs. So it's basically used for classification, regression. Now here we are talking about big English, mathematics, and so on. It's used for clustering, and model evaluation. Maybe I just want to get your idea. When you hear the word clustering with just normal English, what comes in your mind? Go back to primary schools when we are learning about the maps, the map of Kariandusi near Gilgil, the map of a certain location. What comes in your mind when you hear clustering or regression? What comes in your grouping? Perfect. You guys are understanding these topics. You see, are very simple topics. So these things we don't categorization, grouping and putting things together. Awesome, awesome. It's very simple. Simple as it sounds. Simple as it sounds. Just normal English, nothing complex here. When you hear clustering, model evaluation, uh, regression, these are just simple terms. You don't have to complicate your life. Okay, what quote can we relate with scikit-learn? Wisdom is knowing which tool fits the task. And that really explains why we are learning different tools. Every tool fits different tasks. In case we are working with AI, APIs, we know scikit-learn is the tool to use. When you are working with images, we know which tool to use. We know if you are going to decide to use the PyTorch, TensorFlow, those kind of things. If you are working with recommendation systems, we know that we are not going to use the scikit-learn. We know that we are going to probably choose TensorFlow. So each tools performs a certain task based off it a certain tool. So some fun fact here. Scikit-learn powers your spam filter and Netflix recommendations. So each recommendation is totally different from what you know. Depends with how you define the recommendation. What conditions should be met for someone to be recommended a certain movie, a certain video, a certain blog, a certain thing. So recommendation systems work differently depending with the task that you want to achieve. So basically, scikit-learn is best used in your spam filter. That is, for example, in your email, it detects this email is just a spam, and yeah, it categorizes that as spam. With machine learning and AI, it's very simple tools. And one of the most used tools that we use or that we used is the Jupyter. You can call it Jupyter, depends on how fast you had it being pronounced. Yeah, Jupyter notebooks. So Jupyter notebooks or notebook, it's an interactive docs that helps you visualize and write your code. You remember when we are doing week 7, week 6, week 7, week 8 there, we were mostly using Jupyter notebook. So yeah, it's that tool that we use. It's nothing complicated. So as just I said, the tools that you need to use, you can use Google Colab, Jupyter, VS Code, whatever tool that you choose to use. So Jupyter is one of these tools that gives us those different tools that we can use to work around our machine learning and AI. So it's a very great tool. You guys need to check it out. We already covered it. So also we are going to run through it again for those who want to know a different context which you can use Jupyter for. Uh-huh. Let's see some pro tip when it comes to Jupyter. It's a perfect for tutorials, debugging, and collaborative research. For collaborative research. How can you collaborate in Jupyter? We know Jupyter is an online tool, just like Google Docs, Google Sheets, where you can invite someone and they can edit your documents, your code. It's a collaborative tool. You guys can invite each other. Let's say you are working with the engineers in different location, you're not in the same location. Yeah, that's a go-to tool to use for your daily to daily tasks. So sometimes when I don't want to code in my VS Code, I can go to Jupyter Depends with where I am. Yeah, Jupyter is one of the tools that we are going to use for different contexts and use. Okay, the other tool is the cafe, cave, cafe, whatever you call it. Depends on how you know it for cafe. Is it cafe or is it cave? How do we pronounce this? Anyone who can help us pronounce, is it cafe or is it cave? How do we call it? Chakin, do we call it cafe or do we call it cave?
Cafe.
Cafe. Is there any problem if I call it cave?
No much problem. It's just that cave have one F.
Okay, awesome, Chakin. Okay, you can call it cafe. Let's go with Chakin's word. So it's just we call it a speed demon for vision tasks. You can just call it a speed demon. Yeah, why? What do we call it a speed demon? It's a blazing fast image processing. It's image processing. This thing uses C++ behind the scenes. And we know C++ and all those core programming languages, the C, the C++, the C sharp, those are blazing fast languages or that work with processing. And Cafe is one of the tools that is really, really fast when it comes to this task that is image processing. So yeah, Cafe, when it comes to image processing, we are going to use this. And so far you have seen we have so many tools working with images, and you are wondering, when do I know which tool to use when working with images? First, you have to know why and your goal that you want to achieve. Is it image processing, image recognition, image classification? Then that will know which tool best to use. Then of course, if you are creating this program, of course, we blend all these programs together. I know some part is doing image processing, other is doing image recognition, uh, image classifications. Now we blend all these tools together and come up with a legit system. Yeah, so this is another tool that we are going to use for image processing. We have a use case here that we can use for Cafe. Cafe still powers real-time image apps. Anyone who can give us an example of real-time image apps? An example of an app that is real-time image apps, Cafe. Anyone? I'm waiting for your examples on the chat. Pinterest. Oh, wow. I can't digest this. Pinterest. Is it Pinterest or is it Pinterest? Depends again with how you heard it pronounced first. Pinterest. Open interest, whatever you say it. Google Lens, it's image um, recognition, processes images fast. For those who have never used Google Lens is just like a camera where you scan an image. You can scan an image of a flower, then you can submit that and it can tell you what kind of a flower is that and how you can use those different flowers, different contexts. Yeah. So these are examples that where images are highly used, and we can use Cafe for that instance or for that case. So let's check another tool that is the CNTK, developed by our amazing Microsoft. Anyway, I just want examples of some of the tools that are under Microsoft. Tools do you know that are under Microsoft, the company itself? Copilot, awesome, awesome. Another tool, the Pi, Microsoft Pi, Microsoft Azure, VS Code, Teams, Microsoft Word, Office, the Microsoft Office, Microsoft Team, the Outlook, C Sharp, awesome, awesome. I can see you. C Sharp, different Microsoft Power BI. Yeah, we have this Power BI.NET language, Power BI, the Azure, Microsoft Access, Bing. Yeah, awesome. Microsoft Edge, and mostly uses Bing. Let me see. Let me see. Microsoft Edge. Any other tool that you know? Any other tool? And of course, Skype. Awesome. Awesome. Skype. Skype. VS Code, our lovely editor, here, VS Code Skype. And of course, you forgot to mention the Microsoft CNTK tool that we are going to use today. Yeah, Microsoft CNTK. And of course, you guys forgot to mention one of the most incredible tool that is under Microsoft, the GitHub. We use GitHub every time. Yeah, it's also under Microsoft. Yeah, you mentioned it. Who mentioned it? GitHub. Think I missed it. Yeah, GitHub is also under Microsoft. Someone is saying Skype is dead. Yeah, we have other meeting tools that overtook Skype. LinkedIn, our awesome LinkedIn. Yeah, LinkedIn is part of this Microsoft thing. All right, let's go. So how can you use the CNTK, this Microsoft tool? It's optimized for multi-CPU or GPU speed. In case, now here is where you choose, depending on your machine. If you are using CPU, you are using GPU. Now Microsoft CNTK tool can be used for that. So it's used mostly, it's an efficient distributed trainer. So one of the things that you can use CNTK for is for speech systems or voice systems. We know voice systems take a lot of processing power. Now CNTK is the one to handle that. Now, if you use CNTK, depending on the task, for example, voice and speech systems that are CPU intensive and GPU intensive, that's where now the CNTK tool mostly comes to play. It helps you make better decisions when choosing your tool. The Microsoft CNTK, it's now part of the Azure ML ecosystem. Azure, depends it how. You can call it Azure, doesn't matter as long as you get it right. Yeah, it's also part of the Azure machine learning ecosystem. So CNTK, of course, creates some strength when it comes to seamless collaboration. So we are going to see how the demo part, the practical part are going to cover most of these things. How is it CPU intensive? Or how is it optimizing CPUs and our GPUs? The practical part is going to explain everything well. Your machines are going to run perfectly. You don't have to worry. Don't have to worry. So you can check some of our Ubuntu manifestos. Ubuntu manifestos. Maybe someone has been asking, what is Ubuntu? What do you think? Or what comes into your mind when you hear the Ubuntu manifestos, Ubuntu what? Ubuntu wisdom. What comes into your mind when you hear the word Ubuntu? Maybe. Just want to see. Some people learn here about OS, humanity. Humanity, someone is saying Linux, operating system, Africa, Ubuntu. What comes in your mind when you hear Ubuntu? People are saying community. Others are saying it's a Linux OS version or distribution. It's an OS, it's a community, it's a culture, togetherness, gift. You have realized that to what comes into your mind when you hear the Ubuntu? So Ubuntu means depends with the context. It depends with the context. Other times depends when it comes to operating systems and computing. We can talk about the Linux distribution or distro, that is Ubuntu. In other contexts like ours, we're talking about community culture, togetherness. So depends with where you use the context for Ubuntu. So these are some of the Ubuntu manifestos, totally different from Kasongo manifestos. Ubuntu doesn't focus on the AI manifestos doesn't focus. Of course, we have the bottom up manifesto when it comes to AI. Change more as you go large. Anyway, tools thrive when users teach, fix and share. Of course, we are talking about community and code. So these tools work best or thrive when we teach users on how to use them, how to fix these different tools, and inviting others. Of course, one of our Ubuntu manifestos or our community manifesto or our togetherness manifesto is solving real world problems or solving real problems. Anyone can use those solutions. Of course, if we are building for a community, we have to think about scalability. How many people, how efficient. So you think about scalability when we are creating a community tool. You think about how it's going to impact a community or how it's going to scale efficiently. So we have a quote here that we are going to read later after we are done with the class. After we are done with the class. All right, and also, of course, we have different AI tools that you guys can use, and we can say thank you. So let's go to the demo part. The demo part is the moment we have been waiting for. The moment we have been all waiting for. The demo. The demo. So anyway, I'm using Casa in this case, and if Casa fails, I don't have to worry. I don't have to worry. If my Casa fails, I don't have to worry. I have Google Colab. I saw someone saying that me and Chakin, we have the same voice anyway. The moment of truth, the moment we have been waiting for. Let me see. Anyway. No, I don't have the same voice as Chakin. We have different voices. We just have the same vibe, man. Sophia, you can't confuse us. Why are we fighting? Why are we fighting? Why are we fighting here? Why do we have to say we have the same voice with Chakin? Why are we fighting? I can't defend myself in this class. Hi, cousins. Now, what are you doing, man? Anyway, we are cousins anyway. Okay, let me just reshare the slides for those who missed the slides. Let me share. You can refer which step we are at. And someone say our voices are copy paste. People are saying that I don't say cool like Jakin. Cool, sip some coffee. Anyway, I'm going to use the word cool, sip some coffee, so that we confuse you most. We want to confuse. Our goal is to confuse you. Anyway, if our goal is to confuse you can use AI recognition tools, AI voice recognition to differentiate our voices. I quote the Bible tool. I quote. Someone wants me to quote the Bible tool. The Bible tool quote that I can quote is I don't remember the verse. It says, "I'm looking for someone. I'm looking for someone." I saw that. I'm looking for someone. That's the quote that I can get at the moment. Anyway, I'm waiting for you guys to open your week 3. Your week 3 on the LMS, and as well, open your Google Colab. This is the tool that we are going to use for today. So our first tool, go to your LMS, and our first tool is the TensorFlow. The TensorFlow. We are going to flow with it. We are going to flow with this Tensor.
Evans,
Mm-hmm.
we have some hands raised up. Maybe we can hear what they have to say. Maybe I hope they have questions about your presentation, hopefully.
All right, we have some hands raised up. The SK, what do you have to say? You can say hi. Hi, SK.
Hi,
Hi, we can hear you. How are you doing?
fine. I have a question for TensorFlow.
Mm-hmm.
I tried installing it on the VS Code, but it told me to downgrade my Python to 8, version 8, 9, and 10. So is there another alternative that I can use? Maybe Jupyter?
Yeah, you have an alternative. Google Colab. Go to Google Colab. Google Colab here. It's an online tool. Uh, Someone else, who is that? Who? Stanley. Hi. Be someone else. Effie. Effie. You have your hand up. Effie, you can unmute yourself. All right, we can continue. I think we can continue. Where are we? We are here. TensorFlow. Open your LMS week 3, lesson 1, AI tools. TensorFlow. As we just said, TensorFlow is an open source machine learning framework that was developed by Google. And that's why we decided to go to Google Colab, because we know they must make it useful there and with no error. So TensorFlow is an AI tool, or it's an open source machine learning framework developed by Google. It's mostly widely used building and training deep learning models. So we are going to see how and where we can use them. So what are some of the key features when it comes to TensorFlow? Flexibility is one of them. Scalability and compressive ecosystem. What is flexibility? It supports both high-level and low-level APIs. We are going to see what are high-level and low-level APIs. We don't have to worry. You don't have to stress ourselves so much trying to learn the differences. As we learn, we are going to keep learning and knowing the differences. So also, TensorFlow is used for scalability. It can run both in your machine, that is in your CPU, for those who are using GPUs, and those who are using the Tensor Processing Unit, that is the TPU. And TPU is a tool hardware that was developed by Google itself. So scalability, you don't have to worry. You can run TensorFlow in your machine, in your GPU, and also in your TPU. You don't have to worry. It will work in both ends. TensorFlow, it has a comprehensive ecosystems or ecosystem. We have the TensorFlow Lite, the TensorFlow JS for those who are in JavaScript, and also the TensorFlow Extended, TFX, the TensorFlow Extended for heavy tasks. So yeah, so this is the key features, or are the key features of TensorFlow. Once we run this code, we are going to understand the differences and what we can achieve. So let's take an example here. In the meantime, you can copy this code and run it in your Google Colab as we wait to explain what's happening in this code. So here, let's implement a simple neural network using TensorFlow. What is the goal? To classify handwritten digits from the MNIST datasets. From the MNIST dataset, or the NIST, MNIST, NIST, MIST dataset. So where are we getting this dataset? It's going to be automatically downloaded from this piece of code. You don't have to worry where is the dataset coming from. It's automatically going to be downloaded. What kind of a dataset? Handwritten digits. Handwritten digits. So in this code, we have this code. We have several lines here, which we are going to explain. But in case you don't get the explanation, we have a detailed explanation in form of a text just below this this piece of code that's explaining every small thing, everything here. And of course, our code is full of comments for you to understand what's going on. You remember when we are using what do you call it? The Jupyter, we had to include things like the matplotlib, the pandas, and all those libraries. Now, that's the same case when it comes to TensorFlow. We use the TensorFlow libraries and those tools, we import them in our code so that we use them. So the first line here is doing the same. So let me just go to my code where I have this and explain. Let me try to zoom. I'm using Google Colab. So the first line here, the first executable line of code here, of course, is to import TensorFlow. It's to import TensorFlow. For those who are using Google, not Google, but VS Code Casa, in case you want to install TensorFlow, you can just basically do this. Open your terminal and run pip install TensorFlow. In case you want to install a certain version, you can specify is equal to version 2 point, whatever version that you want to install. I think this must be double equal to install the version of TensorFlow that you want to install. So most of the time it's going to tell you to downgrade your version of Python. For example, if I install this, because I'm yet to download my version, it's mostly going, you see, it's telling me that no matching distribution found for TensorFlow because my version of Python might be too high, so I need to downgrade at some point. So I'm here to downgrade. Why should I downgrade anyway? And we have another tool that I can use here. I can downgrade myself anyway. So you import the TensorFlow, import TensorFlow as TF for TensorFlow. Then after that, in this line of code here, whatever we are trying to do, we are trying to load the MNIST dataset that is directly downloaded from TensorFlow building dataset. In TensorFlow, we have building dataset for people like us who are trying to first understand what's going on with TensorFlow. So this MNIST dataset is downloaded directly from the built-in datasets in TensorFlow. And what dataset are we working on? We said we are working on these unwritten digits. So that's the dataset that we are working with. So we say this line of code is going to basically download and load that data. So the dataset is automatically downloaded online source or from an online source and split into training and test sets. You're going to see how, never worry. So the XTrain and XTest contains image pixels data. Image pixel data. While the Y-train and the Y-test contains corresponding digit labels. In normal mathematics and drawing of graphs, we know what is the Y and X axis. We know that by what we know by normal mathematics and drawing of graphs. You know what is Y and X axis. Now, revert that or try to compare that with whatever that we are trying to achieve here. With that idea in mind of the X and Y axis, that's the first step that we can think of when we come to this X and Y kind of stuff. So the XTrain and XTest contains image pixel data, while the Y-train and the XY-test contains corresponding digit labels. Okay, let's see what happens here. So whenever we are drawing a graph, normally we draw by X and Y axis. That's constant. That's not going to change. So the X-train and the Y-train. So we are training this data set, or we are trying to train these models. So the X-train and Y-train, we put them into that list. Then the X-test and the Y-test, then all these we assigned to this data set. So where is this data set? We use the TensorFlow that we just imported right here. We use the Keras tool. We load the data set here. We pass the data set model or function. Specifically, we want the MNIST data set. Then we can load the data, right? Very simple. So this basically is telling us it's just the same. It's just the same like, let me just show you how this happens. In case you're wondering what this line of code is doing in real life application. So in case I wanted to do something on the LMS, I would go to Academy. I would go to Academy. So compare this. Go to TensorFlow, go to Academy, login. All right. So we have entered there. Go to Keras. In the same context, go to LMS and go to Explore Courses. Right? I've explored courses. Go to Dataset. So in the list of datasets, I go to Python, for example. Right? So on that case, I've gone to datasets. When I go to this module Python, in that context, load the MNIST dataset. Check the MNIST dataset. In the LMS, I would go to topic number, maybe number 3. Same case here. Then they load that data. Because I'm in week 3, I can achieve what I wanted. Open that particular topic. Same case happening to here. So in case you're wondering why ... that's the case that is happening in real life. So go to the TensorFlow, go to Keras, check the list of data sets, load a specific data set, that is, take the specific data set, then load that data set. And I hope that's pretty clear. Can see you people are enjoying. You are learning. You are learning this. It makes it simple. Yeah, people you are enjoying the explanation. I think you guys are enjoying the explanation. It's very simple, so you don't have to worry. That's what happens when you see things being concatenated and joined and joined and joined. Yeah, thumbs up, yo, yo, yo. Anyway, you guys, you can send me a very good music that you want us to play along the way. All right. So once we are there, let's continue and try the other parts of the code. So normalize the pixel values of images from original range of 0 to 255 to a range of 0 to 1. Let's explain some English here. Images, videos, and anything are stored in form of pixels. So you don't have to worry at normalize. What is normalized pixels? Images are stored in a form of pixels. How many pixels? It's just like the quality. You see in this case where we are talking about videos like 1080 p, 1080, 720, those kind of values. Now images, yeah, just relate that now to pixels. Pixels like the quality, the clarity. Is image blurry? Is this image too clear? Think about that. Don't overcomplicate stuff. So the image are stored in the range of 0 to 255. We are going to see that. Let's just hold on that. So I want you guys, I'm taking so much time to explain the TensorFlow, the first example, because all the other examples are going to just emulate the same concepts. So you don't have to worry. So this scaling helps the neural network train faster and more reliable. Now let's go back to here. Let's say we have a very big set of images ranging from, I'm just giving a normal example so that we relate it now to computing. Let's say that I'm counting from 0 to 255. I'm classifying things. It will take much time, right? Now, what if I reassign this from 0 to 255 to a range of 0 to 1? Reading from here to here, as a human being, it's going to take less time as compared to 0 to 255. Mathematically, normally thinking about that. Now, when we scale from 0 to 255 to 0 to 1, we mean this scaling helps us or helps the neural network train faster and reliable because it has a very small range of things to check it. So we use the X train and the X test to assign it to the X train divided by 255, the X train divided by 255, the range. Just hold on this code, you're going to revisit later. Revisit it later. Now, we have already imported our TensorFlow, loaded the data, and split it into X and Y axis. Compressed the range. Now we want to build a sequential model which is linear stack for or linear stack of layers, right? It's a linear stack of layers. We know how to write normal functions, normal lists, normal dictionary. Yeah, normal dictionary. So here we create a variable, we call it model. This model, now we do the same thing. Remember what we did here. Go inside this, and that. Same case applies here. Go to TensorFlow, go to Keras, Go to a list of models, then check the sequential model. Same case, go to LMS, go to a list of courses, go to models, then take a specific model. Same case applied here. Go to TensorFlow, check on Keras, go to the list of models, then take or use the sequential model. After that, this model here, our main goal is to flatten or to convert our images or the 2D images, that is 28 by 28 images, into 1D array, that is 784 pixels. Let's debug this. What is flattening here or converting the 2D? The 2D in a normal language. So we convert our things. Let's not think things being like a computer. Let's first relate with what we know as human beings, then we convert it into computing. So when we can say 2D, 28 by 28 is like x-axis and y-axis. Our size of an image is a square. 28 by 28 inches, centimeters, millimeters, whatever. 28 by 28, it's a 2D. Then convert it into 1D, that is 784 pixels. So just treat it as just 784 pixels. Instead of thinking of it as 2D, what if we think it as a one object? Here we take the TensorFlow.keras.layers, then we flatten our image. We are trying now to flatten this image. To flatten is just to treat it as this one here. Mathematically, what is 28 times 28? 28 multiplied by 28. What is 28 multiplied by 28? Take your calculators here, mathematics here. What is 28 multiplied by 28? 784. Yo, awesome, awesome. You guys are attentive. 28 times 28. Joy. Awesome, 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 awesome. 724. It's just like we are doing the same concept here. Flatten is just like multiplying this by this, x and y axis. Have we flattened it? Perfectly. So the next line of code here, what is it going to do? It's going to fully connect it. It's going to a dense layer with 128 neurons and the ReLU activation for introducing to non-reality. Linearity, not none. This is non-linearity. So we want to dense it. We are going to explain what is dense. Never have to worry. So TensorFlow.keras.layers. Then we take the dense layer, take the 128, then activate it by or use the activation ReLU. So in case you want to get this, in case you are wondering where I'm getting these, my descriptions, they are already here. Just go to your elements and read every piece of code here. This one here, you can read all these, the dense. First, the layer applies to 128 neurons, which is the rectified linear units, an activation function. This is just an activation function. So this introduces non-linearity so that the networks can learn complex patterns. So we want, because this is a complex pattern, we want now to use the rectified linear units to use that as the neural networks, the neurons. The other line of code, that is TensorFlow.keras.layers.dropout 0.2. What is it doing? So the dropout layer randomly sets 20% of its input to 0 during training. So we are training something, we have to take, in case we want to achieve 100%, at some point we can't achieve 100%. So we have to give it a deficit of 20%. So if we achieve 80%, we have still passed passed the pass mark. This is the same just like doing exams. When you are doing exam, you have the pass mark, that is 50. Our goal is to get 100%. If we get 80%, we are above the pass mark. The same thing. Dropout layer randomly sets 20% of its input to 0 during the training. So we understand what is this doing here. So this prevents overfitting by ensuring that the model does not rely too heavily on a particular set of features. That's why we are giving it this deficit of 20% error. Yeah, you can make 20% so that we don't overpass or we don't overqualify. So the final dense layer with 10 neurons and softmax activation. So let's see. So each neural network here corresponds to one of the 10 digits, 0 to 9. And softmax outputs a probability distribution. So let's see the code. TensorFlow.keras.layers.dense. We pass our 10 neurons, that is corresponding to the 10 digits, 0 to 9. Then we use the activation algorithm to be our softmax, or method to be our softmax. That is a softmax algorithm or method that has been developed by these tools. Now imagine we are done. The next step is just compiling our code and testing our code. So let's see what we have in our compiling our model. Compiling our model, first of all, we need an optimizer. And our optimizer, we are going to use Adam optimizer. Of course, we don't have Eve. If we have Eve, imagine this optimizer is Adam. But remember, we gave it, because Adam must have an Eve, we gave Eve 20%. So let's use our optimizer. Anyway, it's just a dumb joke. Anyway, optimizer here, we are going to use the Adam optimizer. Adam optimizer adjusts the learning rate during training. Just like Adam in the Garden of Eden optimized Eve to prevent so much sinning. So we had to regulate Eve at some point. So optimizer here optimizes or adjusts the learning rate during training. A very simple concept. So we calculate the loss. The loss is the sparse categorical close whatever. You guys, why are you laughing, man? Someone say correct. Laughing at Fanny is insane. All right, all right. All right, gender equality. Of course, I don't make these jokes to offend anyone. We are just trying to relate with real world things. So this loss function is used for integer labeled classifications. Never worry. What is matrix here? The matrix is going to calculate the accuracy, and make sure that our accuracy remains 80% because we gave 20% deficit or 20% error rating there. Of course, this Adam, we have to enforce Adam with some rules so that we achieve this accuracy. And imagine we are done. Training and fitting the model. What does training fitting the model mean? The model on the training data over 5 epochs. An epoch means one full pass through the entire training data set. One entire pass, full pass. So a full pass can mean, let's say we are running in circles, for example. I have to run one complete revolution, another complete revolution, another complete revolution, right? So an epoch means it's a full pass through the entire training data set. Go through the data set. So the model is going to fit the X train and the Y train. Then how many times? 5 times. Run how many? 5 over 5 epochs. So we say that one epoch is just a complete pass through the entire training data set. And imagine we are done. Now here we can test our data set. That was cool. Cool explanation. Now let's run this code and see if our code runs. Run the cell. It's running, it's running, it's running. Mountain Google Drive. Let's see what it has to offer. Okay, there we go. Let's see what happens now here. Let's see. It is still running. Remember that we have, so the first thing is going to download the data from the Google dataset. There, it's running the first epoch, the first time, running through the data and trying to figure out the data. Successfully, accuracy is 0.8, a good one. 0.9, so we run as many times so that it achieves some level of accuracy, All right, and imagine we are done training our model. So the first time, the accuracy was 0.85. The second time, 0.95, 96, 97, 97. As you can see, the more times we train, or the more times we run through the entire data set, the more accuracy we get and the less loss we get. See, we had a high loss here. That means it didn't understand our data. So it's trying to figure out. The more times we run, the more accuracy we try to get. So imagine that was the TensorFlow, how you can use the TensorFlow, and we have explained the entire code base. Wow, this is a dirty joke, Patrick. A dirty one. Wonderful, wonderful. A very dirty one. I've never used Google Colab. Of course, I use Google Colab to avoid installing so many things, man. I don't have to think so much. I don't have to think so much. I don't have to tire myself. It's too easy. Anyway, in this life, you don't have to complicate yourself. Use the simplest tool as possible. Anyway, anyone with any question before we go to the next example? That must be the PyTorch. That must be the PyTorch. And all that explanation is right here. It's right here. All that explanation I did is right here in the LMS. Don't have to worry where I'm getting all these tips. Anyway, how many people are learning something new? How many people are learning something new? How many people are finding it easy? Wow, you can see you guys, me, joy. Easy as cake, easy as ABCD. I forgot to use the word ABCD. Easy as ABCD. Why do I forget using my terms? It's very cool. Let me use Jakin's word. It's very cool. This essay has screened in a law world. Yeah. Someone is saying that cousins, we are killing with a lot of knowledge, with a lot of skills. So what does yeah, what does the just trained model achieve? Achieve. Uh-huh. Good question. Thank you. Thank you, Marceline. The kind of questions I was waiting for. So let me address this and we go for 1 minute break. So the training model, what we want to achieve is maybe later we want to create a system that, for example, I'm taking reports. I'm doing a manual job. And the kind of reports that I get, these are handwritten reports. Let's assume now I load all those images, I scan all those images and load them. I use these algorithms, I train them, then I can know what best I can achieve with that data. So I'm trying to take these handwritten images or reports, then I train them. Then after that, now I can know what to do with that information. I can write now a Word document. I can see the frequency, how many people are submitting these reports, how these reports relate, what contains in the report, all those kind of things. That's what we are trying to achieve. Is the break enough? Is the break enough? Ah, why is the break not enough? Can banjuka? All right. Anyway, let's continue. Let's continue. Let's continue. Let's continue. Let me just load that. Let me just load that a bit for the next. I don't know if we are going to. Let me think. I don't know if we are going to see all these examples, but if we explain two examples well, that means in the catch-up session we can explain other examples like the keras and the rest. But if we get two examples right, then the rest will be good to understand. Is that okay with you guys, or you want us to explain all the examples? You can type on the chat. You can type on the yard. Two is okay. Yeah, thank you. If we get two examples right, then that means everything is going to be okay. All right, let's continue. The last example. The last example for the day will be PyTorch. PyTorch. So let's see what is PyTorch. PyTorch is an open source machine learning library developed by Facebook, developed by Meta. It's known for its dynamic computation graphs and easy to use. It's very easy. PyTorch, it's very easy. So PyTorch is a dynamic computation graphs. It's used for computation graphs. So this allows flexibility and intuitive model building. It is strong community support. Community means togetherness. So many people are using it. So it has some extensive documentation and tutorials. So many tutorials you can get online. It creates easy with Python. Because we are learning Python, it integrates too easy with Python. It's just like taking tea with samosa. It slaps, it's great. Or tea with sausages. Or sausages with mayai, with eggs. It's too easy, it's too sweet. Or it's just like taking, it integrates too easy like taking the African sausage at the evening. It doesn't slap in the morning, it slaps in the evening. especially when the person selling the African sausage doesn't have one finger, or it have a finger with elastoplast. It slaps like hell. You guys can relate. Oh, my fellow comrades, my fellow cousins. You can relate these things. All right. Where is this thing? Where's this big boy, Keras? I don't want Keras. I want. Anyway, let me show you. Let me create another file. Open. Open a new notebook. Oops. Open a file. Open a new notebook in Drive. I open a new notebook. And in this notebook, we are going to just copy and explain just like we did. I'll explain this. I can paste this code right here. Then what I can do is I can edit this to PyTorch, just like that. And I think we have all the things that we need. Yeah, we have it. Now let's explain what's happening. Of course, we have filled our code with so many comments for you guys to understand what's going on. What the hell is going on here? Am I on mute? No, I'm not on mute. It's recording. I'm sharing my screen. Perfectly. Let's go. Where is it? PyTorch. Yeah, here we go. As usual, you have PyTorch here. For those who are using VS Code and other tools you have installed locally, as simple as doing Python, not Python, oh my gosh, pip install torch. In case your computer doesn't have a torch like your phone, you can install torch like this, and of course it will show you a torch. It will light. You can use your laptop as like when your power is off, you can just pip install torch and then you have your torch on. Anyway, that aside, you can't get it anyway. It's a torch, it's a PyTorch. You can't install torch in your machine. So you pip install torch. Then, of course, we import the torch.nn model, or provides the neural network building blocks. The NN model here. You import in torch your optimize.optim for optimization algorithm. That is the optimization algorithm. Then import torch in torch.nn, import the function SF. It's useful function like activation function. Then you can install the PyTorch Vision or the Torch Vision. So this one, you import datasets and the transform algorithm. Then also in Torch, you can import the utils, then you can import data. Then the data loader, it loads the data. It's very simple. Now you can relate the nesting. When I say you install Torch, and in Torch you go inside the NN function, and inside the NN function, you go in the function. Now you can relate because we have already covered that in the TensorFlow example. So what are we trying to achieve here, first of all, as we continue? So we want to implement a simple neural network using PyTorch. What the hell? Oh, it's the same example, right? Oh, right. It's the same example. We are using the MNIST dataset to use the to classify unwritten digits. Now, you see the same example that we did with TensorFlow. We are going to use it with PyTorch. And we see what the hell is going on. Anyone who has heard the song, What the Hell? What the hell? I heard that from JS Mommy. I don't know if it's a song or she created that for herself anyway. Or maybe I pissed her off. I don't know. We keep pissing them off. Anyway, where are we? Ignore that example. So here, we also want to classify unwritten numbers or unwritten texts. The same example we achieved. So we define the data transformation. What is the data transformation? Transform.tflow to tensor. Transform that into TensorFlow. Convert the images or the NumPy array or the NumPy array pixels from that we're arranging from 0 to 255 into a float tensor that is 0, 0 and 1, 1. So basically, you remember our images are too large and they are scaling from 0 to 255. Remember we said we can't count from 0 to 255. It will take a long time in the normal human context. In the normal machine context, it will take time also. What if we convert that or we use the scale, the linear scales? I don't know what we are calling them in mathematics in high school, but we are doing the scaling. Convert this into a scale of whatever. I don't remember, man. I'm too old. Anyway, we convert that into, we represent that into a scale of 0 to 1. That will be easy for our machine to read. So you transform dot normalize means you transform that from 0 to 1, 0.1307 to 0.3081. We are going to see what these specific numbers are. Don't worry about the numbers. We are going to see these numbers, what they are. So we are going to normalize the tensor with the given mean or standard deviation or computed on MNIST dataset. So this is the code. We define a variable. This variable we are going to assign it to this transformation. We use the transforms. You remember the transform that we imported here from the Torch Vision? It transforms dot compose, right? We compose. So by composition, this is a normal data set or images, PIL images. We take the transform, convert that one into tensor, 0 to 1. This we are transforming it to 0 to 1 instead of 0 to 255, right? Then we normalize our range from 0 to 1.1 to 0.38. We are going to revisit these numbers. Don't worry, these numbers, we are going to revisit them. Don't worry for now. Okay, here, before we revisit these numbers, after we have transformed this one into tensor, we download the data for training from where? From the MNIST dataset. So let's see this example here. You take the string dataset. This is a variable in which we assign it to datasets. Where are we getting our dataset from? Our dataset, remember we imported our dataset from the Torch Vision. These datasets. Datasets dot MNIST or MIST or NIST. So once we download this data, we want to put it into our root file. Then we train, we assign the training to true, downloading to true, and transformation to transform. Okay, that is the training data set. The test data set, of course, we use the data sets. We take it from the MNIST data set. Then we put it in the route. On the route, we set training to false because this, remember that we download the training data. Now we don't want to train it. The training should be false. We don't want to train that data that we are going to download. Why? Remember, this is a test data set. You don't have to train the test data set. The download should be true. You have to download it. Then transform, you set to the transform. Where is this transform coming from? Remember, these transforms are right here. And this transform is right here. Remember this variable here? Is that one. We are using it right here. Very easy as ABCD. We are going to revisit the code and rewrite it and see what really happens. So it's just a quick overview, right? We are done with that part of downloading the dataset. And someone is asking, where is this root? Root/data. Root/data. We are going to see it right here. So don't worry, we are going to see it. We are going to see it. Don't worry. Don't worry. Once we run this code, we are going to see the data. Don't worry. So wrap the data set into data loader objects to enable batch processing and shuffling. So what is a batch size? A batch size is a number of samples per batch. A batch can be, let's say I have a packaging company, or I have a production company, and I want to, or I print books. I can print them in batches. Maybe today I print 100 books, that is a batch. Tomorrow I print 100 other books, that's a batch. Things like that. So that's what we are calling batches, number of samples per batch. So today I can print 10 books, tomorrow 100, the other day 50. So those are batches. That's what we call batch size, number of samples per batch. So what is a shuffle? A shuffle is a tool for training data to randomize data under each epoch. We said epoch is just one complete revolution. We are running through a field, one round, second, third is what we are calling epoch. Take that example. Create the data loader. In this data loader, you are going to pass the data loader. Where are we getting this data loader method function? Remember what we imported here from utils? We imported the data loader here. So you don't have to worry where we are getting the data loader from. Then we pass the train data set, and the train data set is the one we assigned here that we downloaded from the MNIST data set. The training data set, we have to patch it into 64 samples. 64 samples. Remember, say we said the batch size can be, I'm printing books, 10 books, 100 books, that is a batch at once. So we have to pass 64 images or data. Then the shuffle is true. Keep shuffling, keep shuffling. Then the test data set, of course, the test loader. We pass the loader, data loader, from the test data set. Remember, the test data set is right here, that we downloaded it from the MNIST data set. The test data set, it's not going to be trained, so there is no much processing taking place. So we can download it in very big batch sizes. Then, of course, the shuffling should be false, right? Okay. So defining a sample neural network model by subclassing the NN module. Let's see the code and explain what's happening. Class simple NN, we define a class. This is just defining a function. Simple NN class. And we pass this as a parameter here. Then of course we define this method here. We use the init so that we can pass the self here. So we use the super function here that we pass the simple NN dot self dot initialize. We are going to see this. We are going to re-explain this code, so don't worry. It's just a quick overview. So in here, what we are doing here, we are defining the first fully connected dense. After defining the fully connected dense, we input the features, and the features are the sizes of the images. And the sizes of the images were 28 by 28 pixels. That is a flattened image. And the output is 128 features. So the self.fc1, and we are going to see what is fc1, is equals to the linear nn dot, we flatten it into a linear way. So 28 by 28, that was 780 something. Then we add 128. We are going to revisit this. We are going to, it's day one, never worry. It's going to be hard, it's day one. So after this, we define the second fully connected layer. So how do we define the fully connected layer? The same case that applied here. Features from the previous layer, and the output should be 10 classes. The digits of 0 to 9. Then we take the self.fc2 is equal to the nn module, then the dot linear model. Then you take the 128 flattened features, the output features, then you assign it to the 10 classes, or the digits of 0 to 9. Then after that, this one is just a sample example of viewing. Remember that our goal for PyTorch is to visualize, something of the sort. So the forward here, we define a function that is forward, we pass self and the x variables right there, or parameters. So use the flattened dot, flatten the input x from shape, and the shape we are getting it from the batch. Remember that we are patching a batch size. One batch has an image, each image with 128 by 28. So in the x, we assign x dot view. Then we assign it -1 batch and 1 batch. Each image is 128 by 128. So all that, we apply the first layer to the rectified linear units to activate the function to nonlinearity. So the x in the f, and the f here, we assign it to the transform, the f function, the transform function. And this f function was useful function for activation. And the activation, remember that we are using the ReLU activation. Then the f.ReLU is the function from ReLU is the self.fc1, we pass the x. The x is the variable. This variable, you can rename this variable to anything. You can rename this variable to anything. You can rename this function to anything. This is just a variable name that we assigned, just like that. We pass it to the first instance and also to the second instance right here. Then of course, we instantiate the model. The model is just like, because we created it as a function, you have to call that function here. Immediately we are calling that function here. That's what we are calling instantiate the function. So here we instantiate the function just like this. Then after that, what we do, we define the optimizer and the loss function. Of course, we explained the Adam, and the Adam is the optimizer function that we are going to use. And for the optimizer, we use the optim.adam. Then the model parameters is this LR001. We are going to explain this. And actually, to get more explanation of this, it's already here on the LMS here. Meaning of everything, data loader, the init, the optimizer grant, the values, the 5 epoch, the additional insights, everything is right here. So we are just explaining what's happening here. Then of course here we pass the loss. So you want to get the criterion loss here. This is just the same example that we did with the TensorFlow. We are just rewriting it with PyTorch. All right, then over here, now we can train the loop. The loop is just writing a small loop, a simple loop for range. That is running through 5 epochs, 5 times. You are running it through 5 times. Then this one we are going to call the train function. The train is an inbuilt function or built-in function that we are going to call it here, the model.train, the built-in function. Then whatever we are going to train, we are going to train in batches. So we are going to take the batch index, we pass the data, and the target is that specific batch. So of course here we pass the optimizer that we created here, and remember optimizer is Adam. We pass the 0 grad. So the 0 grad is basically a clear gradient for previous iteration. Remember, it's a range. First iteration, second iteration, third, fourth, all the way to the final iteration. That should be the 5th iteration. Then here we give the output of the model. Then of course we define the loss. Remember our loss, we set it to 20% previously. Then the loss should go backwards, or the backward pass, compute the gradient of course. Then optimizer.step. So update the model parameters using gradient. So whenever you produce the first output, the second output, optimize it and step up using the gradients, parameter gradients. And with that, of course, we print all the batches that we want. So if we take the batch index divided by 100 is equal to 0, then we print all the data that we want. We print out the epoch, the data index dot length, how long the data was in that batch, the data set of course, and of course the loss. We compute the loss and we print out the loss. Then we evaluate our model, or we evaluate our loop. And our model here, we use the eval, the eval. So this one sets the model to evaluation mode. The eval helps us in evaluation. So of course, before we print out the loss we have to set it to 0 first. Initially, the correct one was 0. Initially, everything starts at 0, growing up to 80, 100%. Then of course here, we disable the gradient calculation for interference and for interference. So here, once we are done printing out our data, here is where we are stopping our program. For example, the data target.inloader. So we assign the output to the model data that was computed here. So that is computing the data set, the test data. Of course, here we calculate the loss. The loss is equal to plus or minus criterion. That is the output target, or you just get in the sum of the batch losses. So let's say we run one batch, we get losses while we are training our data. Get the loss for the first batch. The second batch, just like calculating all the way to the total items. Of course, this code here, prediction, means here output dot argument maximum. So this one is to get the index of the maximum logic here, predicted classes here, just to get the maximum number of predicted data. Of course, here is just computing the correct percentage here. The percentage here, we just compute everything that is evaluated to true, we compute it right here. The number of items and the number of items in the batch, and you calculate the sum, calculating the correct predictions. And of course, we print out our output. So how do we calculate our test loss? Our test loss is test loss minus the length of the data set that has been computed here. So the accuracy might be 100% multiplied by the correct value that are evaluated to true. Then we print out the tests and the data. So with this example, how we have explained it, if you are given the same problem to solve, would you use PyTorch or would you use TensorFlow? If you are given the same problem to solve now, with that explanation, we use PyTorch or TensorFlow? TensorFlow. Wow, PyTorch, Brian. PyTorch, the first person to hear saying PyTorch. Okay, so that was the explanation. Now let's see the output and see, before we decide the tool, let's see the output. Let me run my code and see the output and determine which I could use. It's running, it's computing, it's downloading the data set. Let's see. So it's iterating through the 5 epochs that we said, downloading the data, going through the 5 epochs. You can see it's training. So the test set is right here. Visualizing, it's training, it's calculating the average loss. Let's see, the output is still computing. So as we can see, as it computes, the first output, you want to train it several times. The first output, we got 95% accuracy. second time 97.1, second time 97.08, 97.3, then 97.4. You see, it kept on improving. So that's how we train these models. You train them as many times as you can so that you get as much accuracy as possible. Yeah, someone is saying very interesting, very interesting. It's very easy. It's very easy. So let me answer some two questions before we call it off. So in the essence, the tests are run on data sets that can be stored in databases, CSV, example. Yeah, exactly, Patricia. Yeah. So the data you download it, then after you download the data, then it runs through for accuracy. Let me see if it downloaded the data. Let's see. Push up, push up, push up, push up, push up. Please stay and need it. There you go. I just got the data. You see this data that was, we said it's going to be downloaded here. So the moment I ran this code, it automatically downloaded the data and it put it in the root folder. In the root folder is right here. It put it here. So it when it downloaded the MNIST dataset, then it downloaded the data in the raw data. You can get the raw data here. All these are images, or these are sample images. Then here is the sample data. All these are different data sets. It downloaded and then it started training with these different data sets. So it has to first download it, put it here, then start downloading the data just like that. It downloaded it here, then it started training the data. Yeah, so I think we can, let me see. I think we can end our session there. Then in the evening session, we can join. We are going to do the same thing, so you don't have to worry so much in case there's something that you missed. You can join the evening session. We catch up. We do the same concept, and we learn together. And hope you guys you have learned something today. In case you have learned, you can give us a thumbs up.